In this video, I want to show you some more examples of logarithmic differentiation. Y equals x2 plus 2 times e to the sine of x over x plus 5 times cube root of 2 plus cosine of x. The first step in logarithmic differentiation is to take ln from both sides of the equation. We have ln of y equals ln of x2 plus 2 times e to the sine of x over x plus 5 times cube root of 2 plus cosine of x. Now, with the following properties of ln, we simplify this expression. ln of a times b equals ln of a plus ln of b. So we can rewrite ln of x2 plus 2 times e to the sine of x as ln of the first expression plus ln of second expression, and then minus ln of bottom expressions, minus ln of x plus 5 minus ln of cube root of 2 plus cosine of x. So the aim of the first two properties, we can rewrite this expression in the following form: ln of x2 plus 2 plus ln of e to the sine of x minus ln of x plus 5 minus ln of cube root of 2 plus cosine of x. Don't forget to put minus for the second expression as well, because all the expression in denominator should have this minus. ln of top minus ln of bottom. Not only for the first expression, this minus should be for all the expressions that are in denominator. Now, with the aim of third and fourth property of ln, we can rewrite ln of e to the sine of x as sine of x. Note that ln of e to the f of x in general is equal to f of x. So ln of e to anything equals to that thing. For example, ln of e to the sine of x equals sine of x. So we can simplify this expression here as sine of x. And about this expression here, we know that cube root means to the power of 1/3. We can bring the power to the front of ln based on this property. When we have a power over or expression, we can bring the power to the front of ln. So we can rewrite ln of cube root of 2 plus cosine of x as 1/3 ln of 2 plus cosine of x. And again, ln of e to the sine of x is sine of x. ln of e to any expression equals that expression. Now we have to take derivative of both sides of the equation. Derivative of ln of y is 1 over y times y prime. Or we can say y prime over y. Note that 1 over y times y prime can be written as y prime over y. Derivative of ln of x2 plus 2 is 1 over x2 plus 2 times derivative of inside, which is 2x. Plus derivative of sine of x is cosine of x minus ln of x plus 5. Derivative of ln of x plus 5 is 1 over x plus 5 times derivative of inside, but derivative of inside is 1. So we don't need to multiply this by 1. Minus, copy the coefficient. 1/3 is coefficient of ln of 2 plus cosine of x. You don't need to do any product rule here. Copy the coefficient and take derivative of ln of 2 plus cosine of x. We know that derivative of ln of something equals 1 over that thing times derivative of inside. Don't forget derivative of inside. And derivative of inside is because of chain rule. Derivative of 2 is 0. Derivative of cosine of x is minus sine of x. Now, if we simplify this expression, we can rewrite it as 2x over x2 plus 2. Note that 2x times 1 is 2x. 2x over x2 plus 2. Plus cosine of x minus 1 over x plus 5. Minus times minus becomes plus. And sine of x multiplied by 1 is sine of x over 3 times 2 plus cosine of x. So we have y prime over y equals this expression. But we want y prime to be isolated. We have to get rid of this y in denominator. To get rid of this y in denominator, we have to multiply both sides of this equation by y. If we multiply both sides of this equation by y, we have y prime equals y times the right side of the equation. So y prime, derivative of this function, y was this function. Y prime is derivative of this function equals y times 2x over x2 plus 2 plus cosine of x minus 1 over x plus 5 plus sine of x over 3 times 2 plus cosine of x. Don't forget that this y was the original function. If you want, you can rewrite your answer in the following form, which is better form for your answer. Y prime equals original function times these expressions. And this is the derivative of this function. Let's do another example. Y equals x plus 1 to the power of sine of x. For finding the derivative of this function, we use logarithmic differentiation. Why we need logarithmic differentiation technique for finding the derivative of this function? Because the base and the power both are dependent to x. So you cannot use simply power rule. You cannot say bring the power down and subtract power by 1. You cannot use power rule for finding the derivative of this function. So the first step, as usual, is to take ln from both sides of the equation. If we take ln of both sides of the equation, we have ln of y equals ln of x plus 1 to the power of sine of x. Based on this property of ln of any expression to a power, we can bring the power to front of the ln. We can rewrite right side of the equation in the following form. ln of y equals sine of x times ln of x plus 1. We bring the power down to the front of ln based on this property of ln. Now we take derivative of both sides of the equation. To find derivative of right side of the equation, we need product rule. Note that sine of x is multiplied by ln of x plus 1. Derivative of ln of y is 1 over y times y prime. Derivative of sine of x is cosine of x times second function plus copy the first function sine of x times derivative of second function. Derivative of ln of x plus 1 is 1 over x plus 1. So this is derivative of right side and this is derivative of left side of the equation. If you want, you can rewrite this answer in the following form. Cosine of x times ln of x plus 1 plus sine of x multiplied by 1 becomes sine of x over x plus 1. Now we have to try to get rid of this 1 over y because we are looking for derivative of this function. But what we have here is 1 over y times y prime. We want to get rid of this 1 over y to have y prime. So we multiply both sides of this equation by y. Then we have y prime equals y times right side of the equation. If you remember, y was the original function. So instead of this y, we can plug in x plus 1 to the sine of x because y is x plus 1 to the sine of x. So this is the final answer. Y prime, derivative of this function, equals x plus 1 to the sine of x. Y was x plus 1 to the sine of x times cosine of x ln of x plus 1 plus sine of x over x plus 1.